So today is the test for anion and test for carbonate. Okay. So for this, what we have to take, I have already taken one carbonate sample here, one carbonate sample which is solid. Now I will add here. Students, please reply. Can you hear my voice now? Can you hear my voice now? Can you hear my voice now? Hello? Very low. Okay. Okay, so next step, first to make a solution. Okay, how to make solution? That adding water, I have told you that all the samples are water soluble. Now you can hear very easily. Now the voice is clear to you. Okay, now here I will add, what is the test for? Now here I will add one mineral acid. Just see that it is the dilute hydrochloric acid. Now here I have to move to the camera to show you that the effervescence are coming out. Just look at that. Just show that the effervescence of gases. Okay. This is the effervescence of gases. Okay. See you. This is for carbonate. Now this is a sample plus dilute solution, solution in aqueous medium, and then dilute HCl. Again, I will show you. This is dilute. Yes, you can see the effervescence clearly. Let's move to the second experiment. So this was for carbonate. Now what is the reactions responsible here? It is the carbonate and acid. CaCO3 plus HCl, CaCl2 plus CO2 plus H2O. This CO2 forms in the form of bubble. Clear? Next is that the test for sulphide. Next is the test for sulphide. Here the test for anions are shown. Test for sulphide. Sulphide S2 minus. Now what is the special characteristics of sulphide? When you open the bottle of the sulphide, this is a sulphide bottle. So when you open the bottle of the sulphide, it's coming with some rotten egg smell. But from the virtual medium you cannot smell it, but you can see some observations there. So what are the observations is that? So again we will take the sample, very small amount of sample, not so many, and then dissolve it in water, and then we will add acetic acid to that, and then lead acetate. So sample plus, that is the OS, sample plus water to make solution, plus acetic acid plus lead acetate. Then we will see the change of the color. Okay, so I proceed to that. So this is the sulphide sample taken here. This is called spatula. Very little amount of sample taken. Very little amount of sample taken. Then water is added to make the solution. Water is added to make the solution. Now you see that the color of the solution is transparent. Okay. Now here, and the sample is totally dissolved. You can see that the sample is totally dissolved. No part is left. Okay. Now here I will add acetic acid and then lead acetate. Okay. This is acetic acid. White PPT comes. You can see it. White PPT comes. And then we will add lead acetate to this. Lead acetate. Already a rotten egg smell is coming out from the test tube. Check that the color becomes black. Okay, the color becomes black. This is the observation. So what we have done, first the sample, then we have prepared the solution, again acetic acid to acidify it, and then lead acid. So this is the black PPT is form of lead sulphide PBS. Now see the reaction. So this is for sulphide. This sulphide is having the characteristic smell of rotten egg. Now what is the chemistry here? Sulphide. Suppose sodium sulphide is taken into as a sample, then lead acetate, it will produce lead sulphide PBS, which is of black color. Lead sulphide plus sodium acetate. So this lead sulphide is of black in color. Clear? So first one was the effervescence of CO2. Next one is there is also an alternate test for sulphide. What is this? The alternate test for sulphide is to use sodium nitroprusside. If we add sodium nitroprusside to the solution, then again it will give purple coloration. Okay. So sodium nitroprusside is not ready now. So when in the next class we will see the sulphide test with sodium nitroprusside. Next, coming to sulphide. As you can see that sulphide are also included in syllabus. SO3 2 minus. Okay. So SO3 2 minus, for this we will take the original sample, aqueous solution, then barium chloride. Just see. taken each time. You can see a very little amount of sample. Now, aqueous solution, just to make the solution. Yes, it is clear. Now, acidify it. Acidify it with acetic acid. And then barium chloride is added. Just see the white PPT here. You can see the white PPT here. Yes, this is the chemistry. This you will get from any book, from net. Okay, but this is for to show you that what is the observation here. Okay, so first see it. Okay, and see the chemistry responsible for that. This practicals is common for class 11 and also plus 12. Okay, inorganic practical, this one. Okay, so just follow that. This is the white PPT is formed. This is the white PPT. Clear? Now we will follow the chemistry responsible for that. For sulphide, sodium sulphide plus barium chloride. It is the solution of NaCl plus barium sulphide. Okay. Okay, so this barium sulphide is of white color. Clear? Next one, I want to show you another one test for sulphide. Another one test for sulphide. Again the sample should be taken. Again the sample should be taken. Then aqueous solution is prepared. Not too many volume of water should be added. Very little amount just to dissolve it. Okay, just to dissolve it. When the solutions become clear, yes, now it becomes clear. Now I will proceed to the next part. Then it should be acidified. It should be acidified and then KMnO4 solution will be added. So for acidification, I am acidifying it. Okay, acidification is done. Then KMnO4. This is potassium permanganate. You show the can see the purple color of KMnO4. This is called volumetric flux. Just taking a very little amount of potassium carbonate, potassium permanganate, I will add it to the test solution. color. So I will add it here. You can see that. Now you can see. Just your observation is that the pink color, the purple color of KMnO4 is discharging. Okay. You can see that it becomes discharging every time. Okay. So this is the an alternate test of sulphide. Okay, so what we have done, first of all the sample is taken, then what aqueous solution of the sample, then acidified it, and then KMnO4. The purple color of KMnO4 is discharged every time. So this is an alternate test. So let's see the chemistry responsible for that test. So this is colorless, this is the chemistry responsible for that. If we add dichromate solution, in the same solution if we add dichromate, then a green coloration is observed. Green coloration is due to chromic sulphate, Cr2SO4 3. This is of green color. Okay, so these are the tests for sulphide. Next, so we have done the carbonate, the sulphide, SO3 2 minus, and then nitrite, NO2 minus. So let's see it for nitrite, NO2 minus. So for this we have to prepare again aqueous solution plus acetic acid plus ferrous sulphate solution. Okay, so let's get ready for that. For this I will take some nitrite sample in test tube, making the aqueous solution of it. Aqueous solution is also transparent, that is totally soluble. Now acidified with acetic acid. Acidification means just to add 1 to 2 ml of the acid, not too much. Okay, depending on the volume of the solution. Next, move to the next part, that is addition of ferrous sulphate solution. addition of the ferrous sulfate, okay, here, just see that a dark brown or just looking like black. This is a dark brown color, but I don't think you can recognize or not. Okay, you can see the dark brown color of that. Can you see the dark brown color of that? It is looking like black, it is dark brown in color. Okay, so this dark brown color is for the test of nitrite, NO2 minus, and also this is also tested by using some acid. Okay, but this is under dry test, this is under wet test, because as it is, we first prepare the solution by aqueous solution, so it is not a dry test, but the dry test is also there, which will be discussed on the another class. Okay, so this was the test for nitrite. So today the test for sulphide, carbonate, sulphide, nitrite, these four anion with their wet test. What test? That is wet test. It is not a dry test. Okay, so these test was performed today. Have you understood it? Now these as the qualitative analysis are having a lots of experiments, so we have to do it step by step. Next day we will do again some test for anions. Okay, when I will take the class, some test for anions, the left anions. Okay, next for cations. In that way we have to go through the step by step method. Okay, so thank you everyone.